The radar screen glowed green in the darkness. Tiny dots pulsed across the cathode ray tube. 4 blips showed enemy vessels moving through black waters 20 miles away. Ships that would never be seen by human eyes. Ships that would die without knowing what killed them. The date was April 28, 1945. The location was the East China Sea. Death would arrive from machines that could think. Lieutenant Commander James Patterson held steady at 15,000 feet. His PB-4Y2 privateer carried weapons that defied everything the enemy understood about warfare. In the bomb bay hung 2 ASM-N2 Bat missiles, revolutionary weapons that would guide themselves to targets, weapons that thought. The radar operator called out bearings and distances. Target bearing 045, range 18 miles. These words would be the last human involvement in what followed. Patterson would release his weapons and turn for home. The missiles would do the rest. They would find their targets. They would kill without further human command. This was the future arriving in 1945. The Bat missile changed everything. It removed human agency from the killing equation. No longer did pilots need to dive through flak to strike ships. No longer did courage and skill determine success. American industrial might had produced thinking weapons, weapons that hunted alone. What the Japanese Navy faced was incomprehensible. Their sailors trained for visual combat, ship against ship, plane against plane. Human skill against human skill. But the Bat missile made such training worthless. It struck from empty skies. It needed no pilot. It felt no fear. The weapon was revolutionary beyond its mechanics. It represented a philosophical shift in warfare itself. America had automated killing. Death now came from algorithms and servo motors instead of human hands. Dr. Hugh L. Dryden led the team that created this monster. Later, he would become NASA's first deputy director. But in 1942, he worked for the National Bureau of Standards. His mission was simple: create a weapon that could kill ships without risking American pilots. The technical achievement was staggering for its time. The Bat weighed 1,880 pounds. Its wingspan stretched 10 feet. Inside that sleek body lived a 1,000-pound ASM-65 warhead. But the warhead was just payload. The real revolution lived in the guidance system. S-band radar could spot large ships at 20 miles. Analog computers used vacuum tubes and servo motors. They calculated intercept courses continuously. They adjusted flight controls automatically. The missile could see. It could think. It could hunt. Development began in January 1942. The U.S. Navy's Bureau of Ordnance saw the future coming. They needed standoff weapons, weapons that could strike beyond anti-aircraft range. The National Bureau of Standards assembled the best minds available: aerodynamicists from universities, electronics engineers from Bell Labs, physicists from research centers nationwide. They had 36 months to revolutionize warfare. They succeeded beyond anyone's expectations. By March 1943, prototypes were flying at Naval Air Station Patuxent River. What made the Bat special wasn't just its technology. Any advanced nation might have built 1 or 2 guided missiles. America mass-produced them. German engineers hand-built their guided weapons. Each one was unique. Each one required skilled craftsmen. America took a different approach: standardization, interchangeable parts, assembly line production. The result was overwhelming. America manufactured approximately 3,000 Bat missiles. Germany struggled to build dozens of their guided weapons. This difference in production philosophy would determine the war's outcome. The program cost $12 million. In today's money, that equals about $180 million. Yet this represented less than 1/10 of 1% of American military production. America could afford to experiment. America could afford to fail. Combat debut came on April 23, 1945. VPB-109 Squadron attacked Japanese vessels at Balikpapan Harbor in Borneo. The mission failed completely. Both missiles malfunctioned due to technical defects. Revolutionary weapons still faced teething problems. But 5 days later, everything changed. April 28, 1945, would mark the first kill by an autonomous weapon. VPB-109 launched another attack. This time, the technology worked perfectly. The Bat missile traveled 9 miles from release to impact. The launching aircraft was already turning for home when the explosion occurred. On the receiving end, Japanese sailors experienced something beyond their comprehension. Death arrived from nowhere. No engine noise warned of approach. No diving plane gave visual warning. The ship simply exploded, killed by a thinking weapon that hunted alone. For the Japanese sailors, this attack was psychologically devastating. Their entire naval tradition emphasized human elements: courage, skill, fighting spirit, honor in combat. The Bat missile made all of this irrelevant. They faced technology beyond their understanding. A bomb that could see in darkness. A weapon that thought faster than humans. An enemy that felt no fear and needed no courage. The technology gap was enormous by 1945. Japan had entered the war with excellent equipment. Their Type 93 Long Lance torpedo was arguably the world's best. Japanese night fighting techniques were superior. Their naval personnel were well-trained and experienced. But while Japan perfected existing technologies, America invented entirely new categories of weapons. The Bat incorporated miniaturized radar, analog computing systems, gyroscopic stabilization, automated control mechanisms. Japanese engineers could examine captured American radar equipment. They could identify individual components, but they couldn't grasp how everything worked together as integrated systems. The conceptual framework simply didn't exist in Japanese technology. This disparity went beyond mere hardware to industrial philosophy itself. American production emphasized standardization and mass production. Every Bat missile used interchangeable parts manufactured to precise specifications. Quality control ensured consistent performance. Japanese production remained largely artisanal. Components were hand-fitted by skilled workers. Each weapon was slightly different. This approach worked for traditional equipment, but couldn't produce complex guided weapons. The difference meant America could manufacture sophisticated missiles faster than Japan could build conventional bombs. American industry had achieved something unprecedented: the mass production of intelligence itself. The Bat's combat record was modest but meaningful. On May 1, 1945, VPB-109 sank a second small vessel off Borneo. The squadron's war diary records this as a successful attack on enemy shipping. The exact vessel type wasn't identified. May 28, 1945, brought the most significant success. VPB-109 attacked the Japanese escort vessel Aguni near Okinawa. The Bat missile struck the ship, but didn't sink it outright. Aguni survived with heavy damage. She limped to port for repairs that would never be completed before war's end. While not a sinking, this attack proved something important. The Bat could engage proper warships, not just coastal craft or patrol boats. Real naval vessels with defenses and damage control systems. June 18, 1945, saw the final confirmed kill. VPB-109 sank another small patrol vessel. Additionally, the squadron destroyed at least one oil storage tank on land. This proved the Bat could engage stationary targets as effectively as moving ships. 3 confirmed sinkings might seem modest, especially considering the massive investment in development and production. Conventional attacks achieved far greater destruction at lower cost. A single successful torpedo bomber mission might sink more tonnage. But this narrow view missed the Bat's true significance. Those three small vessels represented proof of concept. Evidence that warfare could be conducted by machines acting independently of human control. The future had arrived ahead of schedule. Other Bat-equipped squadrons achieved no confirmed successes. VPB-123 and VPB-124 struggled with technical problems. After-action reports described numerous failures. Radar seekers confused by land masses. Humidity damaging electronics. Difficulty distinguishing targets in congested waters. Crews often jettisoned missiles without attempting attacks. Better to waste the weapon than risk bringing armed ordnance back to base. The complex environment of real warfare challenged primitive 1940s electronics. Post-war analysis by the Joint Army-Navy Assessment Committee was brutally honest. The Bat's effectiveness was mediocre at best in actual combat conditions. The weapon worked well in testing against isolated targets in open water, but struggled with the complexity of real warfare. Radar clutter from islands interfered with guidance. Weather degraded performance. Primitive electronics failed regularly. Success required near-perfect conditions, clear weather, isolated targets, functioning systems. Yet even limited success terrified Japanese naval personnel. They had no countermeasures, no understanding of the threat, no effective defense. Ships struck by Bat missiles reported being hit from nowhere. The psychological impact exceeded the physical damage by orders of magnitude. Japanese captains became reluctant to sail, even in areas where no Bat-equipped squadrons operated. The mere possibility of guided weapon attack added to the paralysis gripping Japanese maritime operations. American planners deliberately enhanced this psychological warfare. Intelligence officers ensured Japanese forces learned about the Bat missile through various channels. Captured documents were allowed to fall into enemy hands. Radio broadcasts described thinking bombs. Survivors were allowed to escape to spread fear through the fleet. The Bat missile symbolized fundamental differences between American and Japanese approaches to warfare. America could afford to spend millions developing a weapon that sank only 3 small vessels. The investment advanced technology that would define future conflicts. Japan, meanwhile, couldn't even conceive of such weapons, much less counter them. By 1945, fuel shortages meant ships often couldn't sail. Ammunition quality had degraded due to material shortages. Radar sets frequently failed due to lack of replacement parts. American production methods allowed rapid iteration and improvement. When early Bat missiles showed problems with humidity affecting electronics, engineers quickly developed better sealing methods. When radar seekers locked onto land masses instead of ships, software modifications improved target discrimination. Each problem identified led to rapid solutions implemented across the production line. This systematic approach to problem-solving gave America enormous advantages, not just in weapons development, but in every aspect of industrial warfare. Behind the Bat missile's development were thousands of American scientists and engineers. They approached warfare as an engineering problem to be solved. Dr. Hugh Dryden viewed the project through the lens of aerodynamics and control theory rather than military strategy. His team included specialists in fields that barely existed before the war: servo mechanisms, analog computing, radar technology. These were new sciences creating new possibilities for warfare. On the Japanese side, naval officers trained in traditional warfare found themselves facing weapons that negated their lifetime of preparation. The emphasis on spiritual strength and warrior courage meant nothing against weapons that killed from beyond visual range. The samurai tradition that informed Japanese military culture had no answer to American industrial warfare. Bushido emphasized personal honor and face-to-face combat. The Bat missile made such concepts irrelevant. Bat missile attacks created unique psychological trauma among Japanese sailors. Death in battle they understood and accepted. But death from invisible thinking weapons struck at fundamental beliefs about warfare and honor. Survivors reported confusion and helplessness. They described a sense that they faced something beyond normal combat, something that violated the natural order of warfare itself. While America automated warfare, Japan responded with the opposite extreme. The kamikaze program, where pilots became human-guided missiles. This contrast illustrated perfectly the different civilizational approaches to conflict. The kamikaze program, initiated by Vice Admiral Takejiro Onishi, explicitly aimed to counter American technological superiority through spiritual superiority. "We cannot match American science," Onishi stated, "but we have what they lack: warriors willing to die." The parallel development of these opposite approaches defined the final phase of the Pacific War. Mechanical precision versus human sacrifice, automated systems versus spiritual devotion, industrial capacity versus warrior tradition. American sailors facing kamikaze attacks experienced terror similar to what Japanese sailors felt against guided weapons. Death arriving too fast to counter from attackers who couldn't be deterred. But where the Bat represented the future of warfare, kamikaze attacks were the last gasp of a martial tradition being crushed by industrial modernity. The Bat missile operated within the larger context of America's systematic strangulation of Japan through technological superiority. Operation Starvation, conducted by B-29 bombers dropping magnetic and acoustic mines, had virtually eliminated Japanese coastal shipping by April 1945. Submarine warfare had destroyed most long-range merchant vessels. The Bat missile added another layer to this comprehensive interdiction campaign. While the Bat's direct contribution was minimal, its psychological impact multiplied effectiveness across all American operations. The mere possibility of automated attack paralyzed Japanese decision-making. Ship captains hesitated to sail. Convoy routes were abandoned. Supply lines collapsed not just from actual attacks, but from fear of attacks that might never come. American intelligence officers understood this psychological dimension perfectly. They ensured Japanese forces knew about thinking bombs through careful information warfare. The fear of automated weapons often proved more effective than the weapons themselves. The Bat missile revealed both remarkable achievement and fundamental limitations of 1940s technology. The analog computer that guided it consisted of vacuum tubes prone to failure. Mechanical servos required precise calibration. Radar systems were easily confused by environmental factors. Success demanded near-perfect conditions: clear weather, isolated targets, functioning electronics. These requirements help explain the modest combat record. Of approximately 100 Bat missiles fired in combat, only a handful achieved hits. The weapon worked best against stationary or slow-moving targets in open water, away from land masses that could confuse the radar seeker. Moving targets in congested waters near coastlines or in poor weather often escaped attack entirely. Yet even this limited success proved the concept. Every subsequent guided missile program built on lessons learned from the Bat. Engineers identified critical technologies needing improvement: better radar discrimination, more reliable electronics, improved servo mechanisms. The Bat was less a finished weapon than a proof of concept that automated warfare was possible. A demonstration that thinking weapons could function in combat. A glimpse of warfare's future arriving decades early. The last Bat missile attack occurred on August 13, 1945, just days before Japan's surrender. VPB-109, flying from Okinawa, launched 2 missiles at what crews believed were Japanese vessels. Both missed their targets completely. A fitting end to a weapon that promised more than it delivered, but pointed toward a revolution in warfare. By war's end, approximately 420 Bat missiles had been deployed to the Pacific. Only about 100 were actually fired in combat. The remainder were returned to the United States, where post-war testing continued until 1948. These tests yielded disappointing results. The Navy removed the Bat from inventory by the early 1950s. The weapon had failed as a practical system, yet the Bat's failure as a weapon system masked its success as a technological demonstrator. Every American guided missile that followed incorporated lessons learned from the Bat program. The engineers who worked on the Bat led development of Cold War missile systems. Dr. William McLean, who contributed to the Bat's guidance system, later developed the Sidewinder air-to-air missile, using principles proven by the Bat program. The technological lineage was direct and unmistakable. Military historians debate the Bat missile's ultimate significance. Its combat record of 3 small vessels sunk hardly seems worth the $12 million investment and massive engineering effort. Critics point out that conventional bombing achieved far greater results at lower cost. However, this narrow view misses the Bat's true importance. It proved that guided weapons were practical, that autonomous systems could function in combat, that future warfare would depend on sensors and computers rather than human skill alone. The Bat was the first step toward precision-guided munitions that would revolutionize warfare in Vietnam, in the Gulf War, in every subsequent conflict where American forces engaged. Modern military doctrine traces directly to concepts proven by the Bat missile. The Bat also demonstrated American industrial philosophy, the willingness to invest in revolutionary technology even when immediate returns were uncertain. While Japan struggled to maintain existing capabilities, America explored entirely new categories of weapons. This approach to innovation, more than any specific weapon, determined the war's outcome. The side that could imagine the future and build it would win. America imagined thinking weapons and made them real. Japanese naval records from 1945 reveal profound confusion about what was attacking their ships. Some reports described guided torpedoes. Others mentioned robot aircraft. Still others speculated about death rays or secret weapons. The inability to understand the threat made developing countermeasures impossible. How do you defend against something you can't comprehend? How do you counter technology that operates beyond your conceptual framework? Post-war interviews with Japanese naval officers revealed the deep psychological impact of facing automated weapons. They understood being outproduced and outgunned. They accepted being outnumbered. But being killed by thinking machines struck at fundamental assumptions about what warfare meant. Several officers described feeling that they faced not just superior technology, but a different conception of war itself. The Americans had turned killing into mathematics. They had removed human agency from the equation of death. The Japanese Navy's Technical Bureau did attempt to analyze the threat. But without captured examples or understanding of the underlying technology, their efforts went nowhere. Proposals for countermeasures ranged from the practical to the desperate. Smoke screens to confuse radar seekers. Suicide swimmers to intercept missiles. Electronic jamming equipment that didn't exist. None were implemented before war's end. Japan simply lacked the technological foundation to respond effectively. The Bat missile's DNA runs through every modern precision weapon. The concept of fire-and-forget engagement, autonomous target selection, standoff attack beyond defensive range. all originated with the Bat program. Modern anti-ship missiles like the Harpoon and Exocet are direct descendants. They incorporate the same basic concept with vastly improved technology. The operational doctrine remains unchanged. Launch weapons and let them hunt independently. The ethical questions raised by the Bat about automated killing preceded modern debates about drone warfare by decades. The removal of human decision-making from lethal force, the psychological impact of fighting invisible enemies, the morality of machines that can kill without human guidance. These issues first emerged with the Bat missile. They remain unresolved today as autonomous weapons become increasingly sophisticated and widespread. The questions posed in 1945 have only grown more urgent with time. For the U.S. Navy, the Bat provided crucial lessons about guided weapon development, the importance of reliable electronics, effective target discrimination, operational simplicity. These lessons informed every subsequent missile program. Years of development time were saved. Millions of dollars in research costs were avoided. The Bat's failures taught as much as its successes about what worked in combat and what didn't. The program statistics reveal both achievement and limitation. Total produced approximately 3,000 units. Deployed operationally 420 units. Fired in combat approximately 100 units. Confirmed ships sunk 3 small vessels. Ships damaged 1 escort vessel. Program cost $12 million. Development time 36 months from concept to combat. These numbers show a weapon that achieved limited tactical success, but enormous strategic importance. The 3 ships sunk mattered less than the path opened toward precision warfare. The Bat proved that guided weapons were possible and practical. The ASM-N2 Bat missile stands as a watershed moment in military history. The first autonomous weapon to kill in combat without human control after launch. Its modest combat record belies its enormous historical significance as the ancestor of every smart weapon that followed. For the Japanese sailors who faced it, the Bat represented incomprehensible technology that negated everything they understood about naval warfare. Death arrived from empty skies, delivered by machines that could see in darkness and think faster than humans. They were the first warriors in history to face truly automated weapons. Their confusion and terror marked humanity's entry into an age where wars would be fought as much by algorithms as by soldiers, as much by computers as by courage. The Bat missile didn't win the Pacific War. That victory came from overwhelming American production, superior logistics, and ultimately, atomic weapons. But the Bat showed the future of warfare arriving decades ahead of schedule. Precision rather than mass. Automation rather than courage. Technological superiority rather than warrior spirit. Every guided missile and smart bomb since traces its lineage to those first primitive radar-guided weapons released over the Pacific in spring 1945. Today, as debates rage about autonomous weapons and the ethics of automated warfare, we're still grappling with questions first raised by the Bat missile. When machines can select and engage targets without human intervention, who bears moral responsibility? How do warriors maintain meaning when technology negates human skill? What happens to warfare when killing becomes mathematical rather than personal? These questions, first posed by a 1,880-pound glide bomb with vacuum tube guidance, remain unanswered. The Bat missile achieved little in terms of enemy ships destroyed, but it opened a door that can never be closed. The age of thinking weapons had begun. Warfare would never be the same again. The Japanese sailors who died without ever seeing their attacker were the first casualties of automated warfare. Their confusion and helplessness in the face of incomprehensible technology presaged every soldier since who has faced precision guided weapons. They discovered in the most terrible way possible that the future of war would belong not to the bravest warriors, but to the smartest weapons. Not to those with the strongest spirit, but to those with the most advanced technology. The Bat missile flew into history carrying more than 1,000 pounds of explosives. It carried the end of one age of warfare and the beginning of another, an age we're still living in, still trying to understand, still struggling to control. In that sense, the humble Bat missile, with its modest combat record and magnificent implications, may have been the most important weapon of World War II. The weapon that almost nobody remembers, but that changed everything about how wars are fought. The thinking bomb that taught weapons to hunt alone,